actually. So in the last lecture, we saw that we are going to look at factors affecting SN1 and SN2. Now, the first is the nature of substrate. So please write the topic. Nature of substrate. In nature of substrate, we are going to look at, first of all, SN1, and then we will look at the SN2. So write number 1, reactivity of SN1. Now, when we are talking about the factors affecting, when we are talking about the factors affecting the rate of SN1 or SN2, we have to understand that what is the big barrier in SN1, like which is the slowest step. And if we somehow increase the speed of that particular step, slowest step, then in that case, what is going to happen? The rate of the complete reaction will increase. So we all know as SN1 occurs via intermediate carbocation, the rate or the reactivity depends on stability of carbocation, depends on stability of carbocation. So Edukiran rate is directly proportional to, or rather rate of SN1, we are talking about SN1. So rate of SN1 directly proportional to stability of okay. Now if you look at the carbocation, so carbocation is formed when the halogen atoms is removed. So you have R bonded to X, and when this RX bond breaks, then we form a carbocation with the carbon atom that is connected to halogen. It gets a positive charge. Okay, it gets a positive charge. Now there are few types of carbocation that we can have. We can have a 1 degree carbocation, we can have 2 degree carbocation, we can have 3 degree carbocation, right? So these are the major ones: 1 degree, 2 degree, or 3 degree carbocation. Or we can also have allyl cation, and we can have benzyl cation, and then we can also have vinyl cation. And if you want to look, we can also have aryl, but we are going to look at that at the end. So 1 degree, 2 degree, 3 degree. So this is the three major mainstream carbocations that we are going to deal with. Okay, that we are going to deal with. These are the three major ones, which you have to remember the order. So if I talk about the stability of 1 degree, 2 degree, and 3 degree, these what I can say classical carbocations, which you are going to see in many ways in many things, then obviously 3 degree carbocation is most stable, then 2 degree, and then 1 degree. Okay. When I talk about the degrees of haloalkane, then in that case, what I can say, the rate of SN1, it is fastest in 3 degree alkyne halide, followed by 2 degree, and then followed by 1 degree. Because what happens? 3 degree carbocation is more stable. We have seen this in the basics of organic chemistry. Yes or no? Tell me, guys, is this clear? Anji, बताएं. Mariam Khatun, Tarif, Shahid, Shahid. Yes, Khatun, tell me. Clear, na? 3 degree, 2 degree, and then 1 degree because of the stability of carbocation. Not clear. See, guys, we have seen this in organic chemistry, na? Meaning of benzene, and then last class about the carbocations. So in this we have seen inductive effect, right? So here we, see here, this is 3 degree, this is 2 degree, this is 1 degree. Stability of carbocation, 3 degree is most stable, then 2 degree, and then 1 degree is most stable. Okay, the least stable is 1 degree, then 2 degree, and then most stable is 3 degree. So rate of SN1, you are going to remember it like this: 3 degree, 2 degree, and then 1 degree. Then we have a few special cases: allyl, benzyl, and vinyl. Okay, allyl, benzyl, and vinyl. So we are going to look at these individually. Okay, we are going to look at these individually. Let us look at benzyl carbocation. So when you have benzyl carbocation, so you'll have a benzyl halide also. And benzyl halide is not halogen atom directly attached to benzene, rather it is CH2 carbon that is attached to a benzene ring. Now, if we are going to remove the halogen atom from here, then you will get CH2 positive. Now, this CH2 positive is taking part in a resonance. So this is resonance stabilized. Sorry. Similarly, if you look at allyl, so this is halogen atom connected to sp3 and it is connected to a double bond like this. Now, if you remove the halogen atom from here, then also you are going to look at a CH2 positive. And this is going to give you a resonance stabilized carbocation. So both of these are also what? These are also resonance stabilized. Now, if I look at the now let us look at the vinyl carbocation. So if I look at vinyl, vinyl will have C bond, and which is doubly bonded and directly attached with halogen atom. Now, if you look at this particular bonding here, this is CH2 double bonded with CH. CH is having positive charge. Now, this positive charge, it is present just near what CH2, and this CH2 is what it is sp2 hybridized, which is more electronegative. So it is going to pull electrons. So this is very unstable. Very unstable. Okay, and that is why the vinyl halides, they don't show SN reaction. They don't show SN1 reaction. What happens here? You can say that this is the alpha carbon. This is the alpha carbon, and the alpha carbon is unsaturated. And we will write a separate point that alpha unsaturation, it always decreases the rate of SN. Alpha unsaturation decreases the rate of SN. We are going to look at it later on. But यहाँ पे आपको ये सारी चीजें लिख देनी चाहिए. Is all of you done writing this? Yes or no? Tell me. Till benzyl, allyl, and vinyl. Please write this down. Let me know once you're done. Then we are going to look at the overall picture. So rate of SN1, 3 degree, 2 degree, 1 degree, that you have to remember always. Okay. And then we have to write down a generalized order that what is going to affect the rate of SN1. Let me know once you're done writing. Anyone still writing? Please let me know. Okay, no one is writing. Okay. Now, please see, the rate is going to be, I mean, you can find these words: order, rate, or reactivity. You can call it anything. Reactivity of SN1, it follows the following order. So the benzyl one will be most stable because it is resonance stabilized. Then you have most probably the 3-degree, and then it is almost equal to the allyl, or rather I would say allyl is a bit less. That is why it is greater than equal to, I can have greater than equal to allyl, and then we have 2-degree, and then you have 1-degree. But the most important thing you have to remember is that benzyl is what? Benzyl is the most stable. Benzyl is the most stable, and that is why when you are going to compare the rate of or the reactivity of SN1 towards reactivity of certain substrate towards SN1, then what you have to look, please see, the rate of SN1 is first of all directly proportional to the stability of carbocation, stability of carbocation. Now the stability of carbocation, it is proportional to number of benzene rings on C plus, that means the carbocation. And the next thing that we are going to look at, number of alkyl groups. Number of alkyl group on C plus. Okay. Now, I'm going to make it easy even more. You don't even have to look at the C plus. You just look at the alpha carbons. Okay. So rate of SN1 is directly proportional to number of benzene on alpha carbon. Then the next thing which is proportional to is the alpha carbon is what? The CX bond. Okay. So this CX bond, this is CR. This carbon is alpha carbon. Okay, so this carbon is alpha carbon. And then next we are going to look at the number of alkyl group on alpha carbon. That means the carbon that is directly attached to halogen atom. Write this down, then we are going to look at a few questions. Okay, so you have one question. This is only one question. Okay, C6H5CH2Br, C6H5C, CH3, C6H5, and then you have a comma here, which is probably not shown, comma, and then again another compound. So you have this is A compound, this is another compound, which is B compound, this is C compound, and then at last we have this is the D compound. You just need to count the number of benzene rings attached on the alpha carbon, and then you have to compare the number of alkyl groups. First, you will compare the benzene rings. This is A, B, C, and D. Guys, see, by looking, you will not be able to do this. Okay, by looking at these things, you will not be able to do this. First of all, you have to draw the structure if you want. And at least what you can do is, if you can identify how many benzene rings are there, the C6H5, this component, C6 with anything, C6 with H4 or H5, this is going to be a benzene ring. Okay, so what you have to count, you will write it like this: A, number of benzene ring, and the alkyl group. Then B, and then C, and then D. So tell me the number of benzene ring in A structure is how much? Write in the chat, in the A structure, how many benzene rings are there? How many benzene rings? Yes, Khatun, correct. Here we have 1. Okay. And how many alkyl groups? So see, this is the alpha carbon. Okay. So this alpha carbon is having 1 benzene ring and it is having 2 hydrogen. It does not have any alkyl group. So this will be 0. And then tell me how many benzene ring in the B structure? How many benzene ring in the B structure? 2 benzene rings, right? And now please listen, this particular, this carbon, okay, this carbon, it is having 1 branch, 2 branch, and then it is directly attached to Br. That is why the brackets are the branch. The brackets are branch. So this carbon and this Br is bond. So this is what alpha. So it is having this benzene ring 1, and this is the another benzene ring 2, and it is also having an alkyl group. So it is having 1 alkyl group. Now tell me the C structure, how many benzene ring in the C structure? Yeah, again 2, and how many alkyl groups, Mariam Khatun? Yes, Tarif, correct. How many alkyl groups? So you have to identify the alpha carbon. So this Br, it is attached with this carbon atom. So it is only having 1 benzene ring here and the other benzene ring is here. It is not having any alkyl group. So it will be 0. Now in the D structure, tell me guys, in the D structure, how many benzene ring? How many benzene ring? 1 benzene ring. And how many alkyl groups? 1 benzene ring. How many alkyl groups? 1 alkyl group, right? Very good. Now you have to compare. See, now you have to compare. So which is having the highest number of benzene ring? B and C. Now in B and C, which is having more number of alkyl, if there is a tie in benzene, then you will look at alkyl group. So in this case, I can completely see that B is having what the highest number of benzene ring, and then it is also having an alkyl group. That is why B is greatest. And then we have C, because it is having 2 benzene ring. Then I have A and D, both of them are having what? Both of them are having 1 benzene ring. So I will next look at which is having more alkyl group, because if they are having 1 benzene ring, then the benzene ring is not be able to decide. Okay, so because we are having a tie in benzene, we are going to move to alkyl group. So 1 and 1. So it is going to be D structure after this, because it is having 1 benzene as well as alkyl, and then we have at the last A structure. Got this? Yes or no? Khatun, how to do this type of question? Yes or no? Please tell me. Yes, Tarif, your answer was right. Very good. Deborah, you understood this? See, Deborah, I need some input from you. You don't talk at all in these classes. I don't know why is that. If I'm asking number of benzene rings, at least say 1, 2 ना, कम से कम उतना तो बोलिए आप. कुछ नहीं बोलती हैं बिल्कुल. Write another question. Now, this type of questions are basic. Students is like predict the reactivity of for isomeric bromobutane in SN reaction. Now this will be a nightmare for all the students who ignored the topic of isomers, thinking that, oh, isomers, it will not come, it's not necessary. No, isomers directly questions may not come for sure. Direct questions of isomers are very unlikely. Probability is very low. that you are going to get direct questions from isomers, but they will ask you this type of questions where you need the knowledge of isomers. So if you remember isomers, I'm again repeating this. How to make isomers is very easy. So it is what bromobutane. So you'll take 4 carbon atoms, 1, 2, 3, 4, right? So this is a normal bromobutane. Now in this we have 2 different carbon atoms. The red are the same carbon atoms and the greens are same carbon atoms, right? So from here you can make a green structure. That means you can either put a Br here, and if you put a Br on the red carbon atom, that is going to give you another isomer. So these are the 2 isomers of bromobutane that you can get. And the next is if you are going to prepare butane like this. Okay, so this is also having what? 4 carbon atoms. Now this red one is a singular carbon atom, and these green ones are all the same. These green ones are all the same. So if you are going to make for the green one, it is going to be something like this, attached on the green carbon atom Br. And if you are going for the red one is going to be something like this. The Br will be attached here. Now the thing that you have to do is you have to identify the degree on alpha carbon. So for that you have to identify the alpha carbon. It's very easy. This is the alpha carbon connected to 1 carbon atom. So this is going to be 1 degree. This is the alpha carbon. It is connected to 1 carbon and 2 carbon atoms. So this is going to be 2 degree. This carbon atom here, it is connected to 1. This alpha carbon connected to Br. So 1 carbon, 2 carbon, 3 carbon. So this is going to be 3 degree. And then this is what? This is the alpha carbon. It is connected to how many carbons? It's only connected to 1 carbon. So it's going to be 1 degree. Now, if you are going to identify, so I will write this first of all. This is A structure. This is B. This is C. And this is D. Now tell me which is going to be the fastest, which is going to be the most reactive. A, B, C, D. Mein jaldi bataye. Look at the degrees, compare it, and tell the answer. Yes, Mariam Khatun, very good, correct. Tarif, Shahid, Deborah, please answer quickly. Tarif, very good, correct. Deborah, please answer. Which is going to be the fastest, which is going to be the most reactive here. Look at the degrees of carbon. Look at your notes. I have written which is going to be the fastest, which is going to be the most reactive. No, it's too much time. Shahid, correct, very good. Deborah, you have to answer. I mean, it's very bad. It's like, it's an insult to me. I will talk to, if I have to talk to the team now. So the structure which is 3 degree here, that is going to be C, is going to be the most reactive. Then we have 2 degree, right? So the next one will be B, which is 2 degree. Now I have to compare 1 degree and 1 degree, that is A and D. Both of these are 1 degree. How are we going to compare both of these? So it's very easy. Please see the last carbon atom and then the distance between them. So if I look at the A structure, the last carbon atom is here and it has to go 1, 2 carbon atoms and then the 3rd carbon atom. Okay. But in the D structure, both here you have to move only 1 carbon atom. You move 1 carbon atom and you get both the carbons. So obviously both of these are going to plug in a lot of what? It is going to plug in a lot of more electron density towards the 1 degree carbon atom. Also, what you can see is another way of putting this is, look at the beta carbons. If you are not CBA, no, CBB आएगा, चलो ठीक है, CB तक तो ठीक है, उतना तो हमने भी लिख दिया था. I was asking which is going to be the most reactive. Fair. Now, what if the alpha carbon is not giving you any particular decision? If the alpha carbon is having a tie, then you look at the beta carbon and the degree of beta carbon. Okay. So if I look at the beta carbon here, this beta carbon is again this beta carbon is going to be 2 degree. Right? Because it's connected to this 1 degree and it's also connected to here 1 degree. Now, this beta carbon here also, it is going to be 3 degree. Connected to 1, 2, and 3 carbon atoms. So if you have a tie on alpha, you look at the beta carbon. Okay. So after this, you will have D followed by A. So this is the order. Please write this down. Now, maybe in the answers, if you see now, if you look at the answers in NCERT, or if you take even a guide for that matter and try to look at the answer of this particular question, then you will just look at this particular part. They will write the structure instead of CBDA, but they are only going to give you the order, the reactivity of the 4 isomeric bromobutanes. But how to work on the problems, you will understand only if you start working on it. First of all, I've shown you from where I did not even start from here. I did not take the 4 isomeric bromobutane. I started from butane and how to make the isomers. So there are only two types of of butane that you can make. And then there we have, if you add bromine, then there are 4 different ways in which you can add bromine. There are 2 different ways of writing butane. And if you want to add bromo, that means bromine group, so there will be 4 different ways for that. Okay, chaliye. All of you done with this? Yes or no, please tell me. Now write next, reactivity of SN2. So we are going with green. Yeah. Reactivity of SN2. Now in SN2, we have a backside attack, right? So in SN2, what happens? We have carbon and it is attached with 3 groups. Let us suppose 1, 2, and 3. And here we have halogen atom. So the nucleophile is going to attack from the backside. Now the backside attack will be easy if we have small groups. Okay, so if the alpha carbon is going to have small group, then only the backside attack is going to be easier. So you will write, since SN2 occurs via backside attack, will depend on the number of bulky groups attached on alpha carbon. Attached on alpha carbon. So alpha carbon, all of you know what is alpha carbon. Okay. So if you see here, we have, let us suppose, carbon with CH3, and one more CH3, and then attached to a halogen atom like this. So obviously the attack of nucleophile is going to be very difficult for this. And this is what? This is 3 degree. And if you look at 2 degree carbons, which is having CH bonded to halogen atom, and it is having 2 bulky groups, CH3 and one more CH3. Now this is 2 degree carbon, a bit of attack will be much easier. And if you have, let us suppose, CH2 attached to halogen, and it has only 1 CH3 groups. Okay, so this is now 1 degree. The attack is going to be much easier now. And if you look at CH3X, this is going to be the most easy, or you can write 0 degree for this. This is going to be the most easier attack, followed by this, and then followed by the 3 degree. So if I talk about the reactivity towards SN2, reactivity this is going to be 0 degrees most, then 1 degree, and then 2 degree, and then 3 degree. ओके सो 0 डिग्री में आप थोड़ा सा ऐसे करके मतलब ऐसे बॉक्सेस बना लीजिएगा, जनरली इसको नहीं देखा जाता, 1 डिग्री 2 डिग्री 3 डिग्री ही लिखते हैं, बट यू अंडरस्टैंड व्हाट इज 0 डिग्री. 0 डिग्री की जगह आप क्या लिख सकते हैं? मिथाइल लिख सकते हैं, मिथाइल हलाइड, मिथाइल हलाइड. ओके, मोस्ट ऑफ द केमिस्ट दे अज्यूम 0 डिग्री एंड 1 डिग्री इन द सेम वे. ठीक है, दोनों में कुछ ज्यादा फर्क नहीं करता. 0 डिग्री एंड 1 डिग्री दे अज्यूम इट टू बी सेम. Is everyone done? Yes or no? Please tell me. Done? Done ना? क्या बोलते हैं तो समझ नहीं आता मुझे. Let me know if you are not done. After this, you will write a note. You write here alpha unsaturation. Decreases the rate of both SN1 and SN2. Decreases the rate of both SN1 and SN2. So what is alpha unsaturation? Alpha unsaturation is alpha carbon having double bond. Alpha carbon के पास क्या होगा? Double bond होगा ना. For example, you can have this structure, है ना? And if you compare it with this normal chlorine, so obviously this is going to be faster. You can also have alpha unsaturation like this. I'm giving you all the ways in which alpha unsaturation can be present. Okay, so in the cyclic ring also it can be present. And if you don't have the alpha, then it's going to be greater speed. Third case, you can see even the alpha unsaturation is in where? It will be an aryl halide because it is directly attached to what? Chlorine or bromine or any halogen atom. So this will be slower than cyclohexane. The alpha carbon having double bond is called alpha unsaturation. है? ठीक है, तो इसमें रीजन लिख लेंगे दोनों का, SN1 SN2 का, जब अगर सवाल आ गया कि why it is slower. So please see here. Number one, let us suppose you have CH doubly bonded with CH, sorry, CH2 doubly bonded with CH and followed by a halogen atom like this. And if you're going to break this bond of halogen atom, you're going to get CH2 doubly bonded with CH, and this carbon atom will have a positive charge. Now, this carbon atom having positive charge, it is attached with a sp2 hybridized carbon atom, which is more electronegative. More electronegative. Okay. Now, if it is more electronegative, it's going to pull the electron density from the CH positive, and that is why making it unstable. Therefore, unstable. तो SN1 तो हो नहीं सकता because carbocation form ही होगा, है ना? What you will write? In SN1, the carbocation form is unstable due to presence of more electronegative sp2 carbon atom. Okay, sp2 carbon atom आगे लिख लीजिए bonded to carbocation. Now in SN2, sorry, SN1 में तो ये हुआ, SN2 में क्या हो सकता है? Please write. In SN2, the nucleophile will be repelled by electron-rich pi bond. Therefore, nucleophile will not attack. ठीक है, यहाँ पे आप लोग लिख भी सकते हैं इस तरह से. For example, if you have chlorine and a double bond here, so nucleophile attack here won't happen. Say electronic repulsion. Right next, or writing this blue pen. Nature of living group. Nature of living group. Please write here. LG is living group in SN. Should be able to bear negative charge. है ना, क्या होना चाहिए, नेगेटिव चार्ज वो होल्ड कर सके. दैट्स द फर्स्ट पॉइंट. सो नेगेटिव चार्ज कैन बी हेल्ड बाय larger atoms because they have a large surface area. So right, therefore larger the size of leaving group, faster is the reaction. Like rate of SN. And when I write rate of SN, it does not matter whether it is SN1 or it is SN2. In both the cases, directly proportional to size of halogen, because you are looking at haloalkenes. Now, in that case, we have RF, it will be least reactive, followed by RCl, followed by RBr, and followed by RI. This is due to size, because the size of fluorine is smallest, the size of chlorine and the size of Br, and then the size of iodine is the largest. Let me know once you are done writing. Which will give faster SN2. इन दोनों में से कौन देगा? Let's suppose this is A structure and this is B structure. SN2 and Y. Y. भाई अभी तो पढ़ाया यार, किसका ज्यादा होगा? Yes, Khatun, correct. Why Khatun? Why A will be faster? Please write it down because I can't hear you at all. Why will be A faster? Yes, very good. Because iodine is larger in size. Na? The R groups are same. The only difference here is what? In the halogen atoms, iodine and chlorine. And we will say A is faster. Because iodine has larger size and therefore a better living group. Yes. Okay. Now after this, write nature of solvent. Nature of solvent. Now you are going to write 2 points and then we are going to write some remarks. जिसका आपको समझ में आ जाएगा क्यों ऐसा होता है. Okay. Right, first of all, polar protic solvents. Now, what are polar protic solvents? Polar protic solvents such as you will have water, alcohol, acetic acid, right? All of these are what polar protic solvents. That means they're able to give H plus ion. So, for example, water, alcohol, or acetic acid. Okay, these are the examples. Polar protic solvents increases the rate of SN1 and hinders reactivity of SN2. That is why what we are going to use in SN1. In SN1, we are going to use polar protic solvents. And then write next, polar aprotic solvents. Polar aprotic solvents will be examples. For example, you will have acetone, acetone, etc. These are polar aprotic solvents are used in SN2. Then you will write next point. Polar protic solvent PPS increases the rate of SN1 by stabilizing the carbocation through solvation of allied ion. Through solvation of allied ion. ठीक है, ध्यान सुनिए क्या होता है यहाँ पे. We have carbon and halogen bond. ठीक है। अब कार्बन एंड हाइड्रोजन बॉन्ड, ये तो कार्बोकेटाइन यहाँ से निकल जाएगा, यू विल हैव लेट्स सपोज यू हैव CH3 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 here. I will get a positive charge here, carbocation, and X negative. Now, if you look at water molecule, so water molecule, it has H2O like this. So this is delta negative, and both of these are what, delta positive. So this X negative will be surrounded by the water molecules like this, because it is what, delta negative. So ये इसको H plus ions क्या करेंगे? So they will be solvating it, huh? यहाँ पे positive है, delta positive, and यहाँ पे भी delta positive, and here you have negative, so there will be interaction, and they will be solvating it. And similarly, the O negative part will be solvating the carbocation, because O is delta negative and there will be positive. So इन दोनों के बीच में क्या हो सकता है? Interaction हो सकता है. That is why it is going to solvate these both of these things. ठीक है? That's the reason here why polar protic solvent increases the rate of SN1 by stabilizing the carbocation through solvation of halide ion. Right, next. Polar protic solvent. Polar protic solvent hinders SN2 as the solvent is also electron rich and can attack RX. ठीक है, चलिए कितना लिख लीजिए? Tomorrow we are going to look at reactions of nucleophilic substitution. ठीक है. For example, if I have something like this, and if I add NaOH, तो फिर क्या प्रोडक्ट मिलेगा, है ना? NaOH की जगह KCN हो तो क्या प्रोडक्ट मिलेगा, KGCN हो तो क्या प्रोडक्ट मिलेगा. All of these things we are going to look at tomorrow. Reactions of nucleophilic substitution. Let me know if anyone is still writing. Whatever we are doing daily, please उसको revise कर लिया कीजिए, ठीक है?